So for this section with the 4030 machine, we're going to talk about the extra bits that come with the machine to actually get it going and started. So for example, when I first unboxed it, I had my tooling guide as well. So this is tools that the machine comes with, but also tools they sell additionally. And what they look like is this. I actually have a whole series of tools. Now I'm going to open this here, but actually we're going to see a lot more when we go on to the machine. They've got these blue ends, okay, and I don't know if you can see, but you'll be able to see when we get it on the machine. They actually come to like a V tip on these tools. So these are very, very small engraving tools, okay, used for some very intricate fine detail work and some of the 3D engraving as well. But there are various tools that you can use with the CNC machine. The most common tools that you get, one is called an end mill or a slot drill. That looks like a traditional flat bottom. And the other one is a ball nose tool, and it's got a ball looking end to the bottom of it. Now that's typically used for 3D carving work. As well as that, you get V-bit, so that's a typical V shape at the bottom of the tool, and this is used for something called V-bit carving or very fine detail relief carving. If you are just cutting stuff out or pocketing is basically just routing out a section, also called area clearance, then you want a flat bottom tool as well. So we'll go through some of those tools, but there's other things that we have to do before we set up a tool. So we will be zooming in and having a look at this. The 4030 comes with a touch probe. Now what this is for setting the height of your tools. Okay, so you set your height of your tool so you know exactly where it is in the machine. I'm going to leave that to the side for now because it is going to be something we look at. The next thing that we look at is clamps. So how do you hold your material to the bed? There is lots of ways of doing this. Having a clamp is a preferred method because it holds it down. When you get up to bigger machines, more professional machines, they have vacuum beds, so it just sucks the material down. But on the hobby sorts of machines, you have these sorts of things, which basically you have this sort of method, and it kind of hooks it, pulls it down. So this bit goes on the other side, and it kind of pulls it down to the material nice and tight as well. So we're going to sort of see how we can clamp some material down. We are going to set up our tooling as well for this series. So adding a tool, what tool, putting our material down to the board and clamping it down. Another thing that people use is double-sided sticky tape as well. And then as we go through this series a little bit further, we'll talk about waste boards and other cutting practices and best practices that are used as well. So let's get over to that machine and have a look at what we're doing. So the first thing we're going to take a look at is adding a tool into this. So the 4030 actually comes with the ER11, which is this, attached to the spindle, and the spindle already in place. This is different than the 3018. So you have two spanners, which this is exactly the same process, which you just need to loosen this off. And we can take a look at what this is made up of. Okay, now in the 4030 and the Sainsmart products, these two pieces are together. In a few other brands you won't find that this is all put together for you, so it's really nice, but it's useful to know this is called a collet. Okay, and they come in all different sizes. Okay, typically you can buy them in a pack with these yellow boxes, and they have all different size ends. So if we take a look at the difference between this and this, you can see the hole and this one, the hole is much larger on these. Now what these are for different size tools. So you don't have to just use the size of tools that come with the Sainsmart machine, which happens to have a shank of 3.175 millimeters. Now to explain that, on a tool, this section here is the actual shank, and this is the cutting end itself. Now you can see that this shank here would fit into a 3.175 millimeter hole. So that's perfect, but you wouldn't want to use this tool in these because it won't fit. So you need to make sure you have the right collet, okay, collet for your tool shank. Okay, so I'm going to take the collets out of the way. Now you can buy these collets. For this machine it's the ER11 collets that you would want, and you can just buy a pack of them and they are not expensive. The next thing to know is that the collet goes in like this way round, not the other way round. Okay, it won't go in that way round. Push it in that way round. So the tool will go in here and it'll be slid up. Okay, just going to pull it out a little bit. Now you need to make sure this nut is on. Now you have to think that this spindle, in this case, is spinning at 12,000, or has the potential to spin at 12,000 RPM. So you need to make sure that it's done up tight. Now rather than pushing it in the bottom, I've clicked it in here because it will click in there, and I'm just screwing it on there loosely. Now this is where a sort of a bit of finger play comes into work, because you slide it up to where it needs to be, and then you need to tighten the bottom nut to the top. So I'm holding it here and tightening the bottom, and then it will stay in. Now you need to make sure there's a decent amount of machining in there. The reason being is that you don't really want this bit here to go into your material because it will catch. So you need to make sure there is a decent length, but still a decent length in there too. So that's probably about right. If I get another tool so we can look at the distance that's gone in, okay, we can see there's a good third of the tool, possibly more, which is in there. So that's about right. Now the next bit is why you have the two spanners. Okay, so that's going to clip on there and there, and you need to make sure it is tight. This thing will spin, and if it is not done up tight, it will fly out. So that's it done tight. I am going to turn this on so we can watch this spin. First of all, I need to turn the machine on because I haven't turned it on today. So first of all, we're going to turn the machine on. Now on the 4030, we are using the spindle control on the controller board itself. So this should be very, very simple. Make sure the stop switch up, and then just turn in the actual spindles. So simply we'll just turn up the spindle speed so you can watch it actually rotating round. and that's how the spindle goes round. Okay, so that's how we do our actual tool and place our tools in. Whatever tool we use, it's the similar process to how we do it. So the one thing that comes next is to measure your tool itself. So we're going to take a look at that process. Now there's a couple of ways of doing it. I'm going to show you firstly the older way to do this. So this will also bring in our actual clamping of our material. So I'm going to move the gantry up, and we're going to take an actual look at placing some material on the bed. Okay, so you may hear of this one being called the piece of paper method. I'm going to place that in. Now I'm going to put the actual clamps in place. So I'm just going to pop them down, and then we can take a look at the clamps afterwards. So just tighten that one up, and I am going to place another clamp on as well. For this process, we're just measuring the tool, so it doesn't matter too much because we're just focusing on the methodology behind actually setting our tool height. So this is a sort of non-automated process of actually setting your tool height. So I'm just, while we're on here, I'm just popping another clamp. I'm just going to pop this in diagonally, but in reality I would be popping 4 clamps on. Typically always end up using 4 clamps on a job to hold it in all 4 corners. That will stop it from moving. Right, so we're going to screw that in there. As far to the edge as it goes. Okay, something similar to that. And we're going to use this piece of paper method. Okay, so that is firmly in place. The wobble is actually on my table itself. So to set the tool height, I have actually got candle open. I've got my spindle running, so I'm actually going to turn my spindle off. Okay, so now what we're going to do in candle is I'm actually going to move our Z down. So our Z, or our tool, will go down reasonably close to the bed itself. Right, so I've manually moved that down. That may be a bit low, so I'm going to change my feed rate to go a bit higher. Sorry, a bit lower in figure so I can move it higher. Okay, so as I said, this is called, it's an older one, it's a piece of paper method, where you basically find a piece of paper that you have lying around, or anything available. Now I'm going to use the paper that has all of those tools on. As you can see, it's probably a little bit large, so I'm still going to use it though. So, and I'm going to come from this side. As you can see, the tool itself, actually the paper moves freely. Now what I'm going to do is just move the tool down gently until the paper no longer moves, and then it's at the top of the block. So we're going to move in the Z, and as I do this, I'm just going to be slowly. Okay, so that's stopped there. I may have gone down a little bit too much. Oh, it's just dragging there, so maybe just down one. A little bit more. Okay, that is the top of the block. So now what I would do is use that as my Z0, my zero of my Z. So top of the block, that is exactly the top of my material. Don't forget, if you're doing this, to increase it back up so I can move the tool up. Okay, so that is what is a much older way of doing this. In theory, it is less accurate than using something like a probe. Okay, something like this, okay, which does come with this machine, so we can set the probe up itself. But if you really want to get running fast without setting this up, this is the best way to do it. Now, the other thing is your origin on your material. So in this case, it would be the center of the block. So the best way to do this is to actually measure it, draw a mark, measure it, draw a mark, and mark in the center. Now, a lot of people go for the center, and that's fine on something that's round, square, rectangular, something easy to mark up. But if you have an irregular piece of material, you can use a corner, but center is going to work quite well for this. So let's look at marking up this material. So if you haven't got any or don't already own any, first thing you want to buy yourself to be able to actually use CNCs and work with CNCs is a pair of calipers. Okay, very, very useful for various different things. Measuring tools, measuring the diameters and the thickness of material, and actually finding center points quite usefully. So I'm going to measure my material. Okay, so it's 200 millimeters, so I'm just going to quickly mark in 100 millimeters there. I can appreciate this may not be 100% accurate at the moment. Okay, so somewhere along that sort of line. So I'm going to pop in on my calipers 100 millimeters. Or as close to, and then I am just going to mark various points. Along it. Okay, and we're looking somewhere about there is the middle of the material. So the next thing I need to do is to set up my X and Y in candle. So I'm just going to move the tool down a little bit, jog it. Probably going to go down a little bit more. I'm going to reduce the feed. And then I'm just going to jog my tool into place. Okay, so this bit takes a little bit of time to get right. And then, give or take, that's roughly the centre of our material. Because that's the centre of our material, we push the 0 coordinates. We can actually write down the machine coordinates from Incandle as a reference point as well, in case anything does happen with our machine. So the next thing for me to actually do would be to run a job, okay? Because I've got my tool height set, I've got my material in and clamped, so I'd be looking at running a job. But before I do that, I'm going to take you through the other method of setting a tool height from using the automatic method by using the touch probe. So we're going to set that up now as well. Okay, so this is our actual probe, and the tool will actually just come down and touch that and retract out. So what you do is, first of all, you need to measure the height of this to set it in the candle software. So this is where the calipers come in very, very handy, and you basically measure the top and bottom of that material. So it's 20. It's actually 20.1, 20.08, let's try there, 20.04. Okay, we're just going to go with the 20, keep it very, very simple that it's going to be 20. So in the candle software itself, you need to set up that exact height. So first of all, you need to go to your settings. So in 117, it's service and settings. I'm just going to expand this for us. Okay. And in Candle, you can see there's a lot of different options. Okay. So you have a lot of different information here. And you go through and click them. Here we go. Now it starts to change. Okay. Now we're going to leave all of those alone, and we're going to go to the connection option. And don't forget, at the start is your actual port, which is your COM, which is where your USB is plugged into on your laptop. Okay, but actually down here, the probe control is actually this here, so Z14. So what I'm going to type in here is I'm actually going to type in Z20. And then just OK that. So now when I click this on here, I actually need to make sure my machine is turned back on. So I turned it off to do a little bit of the wiring of the probe itself. Okay. Just checking it is jogging. I'm going to move that underneath, and now it is fully set in place. I can hit the probe button and see what it does. So the probe button is this one here, and the tool should go down and touch it and come back up. And retract. So that has set the coordinates for me. So that's the height of the tool. So this is automatically setting your tool. Now you can do this itself for every tool. So if I change this tool and put an end mill or a ball nose tool, I can use this exact same process to set the height of my actual tool. So a way to check this is it looks right, it's actually moving my Z down till it goes roughly to 0. Now one thing I like to do with CNCs is double check everything I possibly can. So actually that is sitting too high. So actually my measurement was probably out because I counted this as the top of my material, which is sometimes why I like to use the piece of paper method, because I actually counted the top of the material 1 millimeter lower than it actually set it as. So this, you need to make sure that your calibration of this is correct and your calibration of this. So if I redo this and re-zero my settings, and actually take it from the metal itself. Oh, 0. Let's wind it up. Okay, and take it from the metal rather than the plastic rim. Okay, it's 20.15, but it's still not that millimetre down. So you really need to make sure that you get your Z height correct, otherwise it won't be to the depth you expect it to be. For me, I like the piece of paper method because I know it's only a small amount between the top of the material and the paper. So that's why I still use that methodology of actually setting them. Okay, so now, if you're happy with how everything's set, the very next thing you would do would be to start a job and machine. So that's basically everything set up ready to machine. Okay, now I'm not sure I've put these clamps correctly because I would be worried about this hitting them. So the clamps probably aren't put in as they should be. I'm very worried about this and how close that is to that. Personally, I'm also very worried about the height and the clearance as well. So something to look at, but for doing a lot of jobs, this is absolutely perfect. You can get longer nose tools if you need to do more depth, or actually it looks like I can move my Z actually down a little bit as well, just so I can make sure that I've got some good clearance in here. Another thing is you can also print, a lot of people are 3D printing dust extractors to go on these. Dust extractors are brilliant because it stops everything going everywhere. So that's another alternative for these machines, is a extraction unit. But if you just want to get running and going quickly, setting up the machine, everything I've shown you, you can see and you can get running with as the machine is now.